Hello, mathematicians. Today we're going to be learning about proportional and non-proportional relationships using graphs. So here we have a table that represents the relationship between hours and costs of bike rentals. So here we have 0, 0, representing after 0 hours, the cost will be $0. We have 1, 3, representing after 1 hour, it'll cost $3. 2, 6, after 2 hours, it'll be $6, and so forth. So if we notice, our x does have a pattern. Our x values are increasing by 1 hour at a time. And our cost also has a pattern. It's also increasing by the same amount, but it's increasing by $3. So we know that every hour that passes by, an additional $3 will be charged for the bike rental. So in order to check to see if it's proportional or not, we do have to see if we have equivalent rates. So if the cost is $3 for 1 hour, we have to see if it's equivalent to the rest of these. So we have $6 every 2 hours. For 2 hours. Then we have $9 for 3 hours. And then we have $12 for 4 hours. $15 for 5 hours. And $18 for 6 hours. So if we simplify our rates here, we know that $3 over 1 hour is fully simplified. $6 for 2 hours simplifies to $3 an hour. $9 for 3 hours simplifies to $3 per hour. $12 for 4 hours simplifies again to $3 per hour. $15 for 5 hours simplifies to $3 per hour. And $18 for 6 hours also simplifies to $3 per hour, making all of these rates equivalent. So because these rates are equivalent, we do know it's a proportional relationship. And the constant in proportionality is $3 per hour, so just $3 an hour. So we could erase this. So our constant in proportionality is 3. And if we wanted to write an equation, we'd write y equals 3x, because x represents the number of hours, 3 represents the cost per hour, and if we take the hours and multiply it by 3, we'll always get y. So 1 times 3 is 3, 1 times 2 is 6, 3 times 2 is 6, 3 times 3 is 9, and so forth. If we wanted to predict how much it would cost for, let's say, 10 hours, all we would have to do is, we're looking for the cost, so y equals 3 times 10. And since I said 10 hours, that would be x, and here we would solve for y, which equals y equals 30. And if we wanted to, if we knew that the cost was, let's say, $36, and we wanted to know how many hours that is, we would substitute the y for 36. So I'll write it on top of each other so you guys could see it. So y equals 3x. And if we knew the cost was $36, we'd substitute y for 36. And then bring down the 3, and we'd write x because we don't know the number of hours it takes to pay $36. And so we just divide both sides by 3 to solve for x. And then 36 divided by 3 is 12 equals x. So for $36, we could rent a bike for 12 hours. So don't forget that the 3 is our constant of proportionality. It's our rate of change. And it's our slope. Okay? And so if we wanted to graph this, the first point we'd start off with is 0, 0. And then 1, 3. 2, 6. 3, 9. 4, 12. 5, 15, and so forth. So because we know our line continues, when we do draw our line, we're going to make sure that it has an arrow at the end to represent that it can keep increasing the more hours we rent the bike. So as you see here, we didn't have room to plot 618, but our arrow up top tells us that this line keeps on going. So here we have another example, and in this case we also have a bike rental, with the exception that the cost is a little bit different. So if we look at our table, we could see that this one also increases by 1 hour at a time to show us the different costs for different hours. So +1. And then if we look to our y's, which is our cost, we see that our cost is actually increasing by $1 each time. So as the hour increases by 1, our cost is increasing by $1. So here we pay an additional $1 for each additional hour. And if we wanted to see if it was proportional, we'd have to write down our rates and see if they were equivalent. So for 1 hour, it costs $7, so it's $7 an hour. We know that it's $8 for 2 hours. $9 for 3 hours. $10 for 4 hours. $11 for 5 hours, and $12 for 6 hours. And so if we simplify our rates, $7 an hour is already simplified. That's our unit rate. And then we have $8 for 2 hours. If we simplify that, that ends up being $4 per hour. Here we have $9 for 3 hours, which ends up being $3 an hour. Here we have $10 for 4 hours, which ends up being $2.50 per hour. Here we have $11 for 5 hours, and if we divide that, it ends up being $2.20 per hour. Here we have $12 for 6 hours, which ends up being $2 an hour. And these are not equivalent. So this is not a proportional relationship. And even though it increases $1 per hour, it's not proportional because here initially for 0 hours it costs us $6 just for this bike rental before even being able to use it. And that's what causes it not to be proportional. So if we go back to our previous example, it starts at 0, 0, making all of these rates equivalent because it increases $3 per hour. But because this one started at 0, 6, these rates are not equivalent. So even though it may be $1 per hour, this is not a proportional relationship. However, just because it's not proportional, we could still use an equation to represent it. So our first relationship was proportional. Our second one is non-proportional. And we could still represent it using an equation. So y is the cost. Y equals to the hourly rate, which is $1 per hour. So $1 times the number of hours plus our initial value of $6. So here we have our rate of change, which we could also call our slope. And here we have our initial value, which is also called our y-intercept. And I'm going to show you guys why that is. So here when we're graphing, all right, we have to be mindful that we're starting at 0, 6 this time, not at 0, 0. And this is why it's not proportional, even though it increases at the same rate. So after 1 hour, it's $7. After 2, it's 8. After 3, it's 9, and so on. So here I could draw a line to show that this will keep on going, depending on how long we rent the bike for. And so if we compare, our proportional relationship starts at 0, 0 and increases at $3 each hour, $3 per hour, $3 per hour, $3 per hour, $3 per hour. However, our non-proportional relationship starts at 0, 6, so not at 0, 0, but it still increases at $1 per hour. So it's still a constant rate, but it's not proportional because we're starting with an initial value, making our rates non-equivalent. And even though this is not proportional, we could still use an equation to represent it, and we could still use it to predict future costs. So if we knew we wanted to rent the bike for, let's say, 10 hours, all we would have to do is substitute our x, so y equals 1 times 10 plus 6, so $1 for the 10 hours, which is $10, plus the $6 initial fee, which gives us 16. Or if we knew that the cost was $20, it would be 1 times x plus 6. We'd have to solve to see how many hours it would take for it to cost $20. So we would just solve for x, subtract by 6 on both sides. 20 minus 6 is 14, is equal to 1x. Divide both sides by 1. X is equal to 14. So for $20, we could ride this rental bike for 14 hours. Here we have another example. So here we're talking about a dancing club and the relationship between the months and the cost. So if we look at our table, we'll notice that the months increase by 1 at a time. However, we don't have our cost here, but if we look at the graph, we could take our line here and use it to fill in our table. So if we look at our line, we could draw coordinates. So here our graph starts at 0, 0. Our next point, our next exact point is 115. Then we have 230. Then we have 345. Then we have 460. And then we have 575. So we have 0, 0, 115, 230, 345, 460, and 575. So our graph does not go higher, so I'll leave that blank for now. If we notice on our table, we could see that the months are increasing by 1. And our cost here is increasing by $15. And so if we continue this pattern, we could actually figure out how much it would cost for 6 months. So it would cost $90 if we added 15 to 75. So here we're increasing by the same amount for our x and for our y. So let's see if this is a proportional relationship. So we paid $15 for the first month, $30 for 2, $45 for 3, $60 for 4, $75 for 5, and $90 for 6. Okay, so here if we simplify our rates, $15 for 1 month, that's completely simplified, that's our unit rate. And then if we simplify $30 for 2 months, 30 divided by 2 is $15, so this is also $15 a month. $45 for 3 months, if we divide that, we end up with $15 a month. $60 for 4 months, we end up with $15 a month. $75 for 5 months, same thing, $15 a month. $90 for 6 months ends up simplifying to $15 a month. So as the months increase, so does the cost by 15. We have a proportional relationship because our rates are equivalent, and we start at 0, 0. So there's no initial fee for a proportional relationship. And if we're looking at our graph, we could also tell just by looking at our graph without looking at our table, if it starts at 0, 0 and is a straight line. So here we start at 0, 0 and we're increasing at the same rate at a time. So $15 per hour, $15 per hour, $15 per hour, and so on. So we have a proportional relationship, and our constant of proportionality is 15 because, sorry, not per hour, per month, because we're paying $15 per month. So we have y equals 15x. And so remember that the 15 is our constant in proportionality, and it's our rate of change, and it's our slope. And so if we wanted to use our equation to help us make predictions, we could substitute either the x or the y, depending on what we were trying to figure out. So let's say we want this membership for the dancing club for 20 months. So since x is months, we would substitute x. So we would substitute it for 20. So y equals 15 times 20, and 15 times 20 is equal to 300, so y is equal to 300. So for 20 months, it would cost $300. And so if we wanted to substitute y would represent the cost. So let's say we wanted to know for $525 how many months that could be. We would write 15x. So in order to solve for the number of months, we would have to divide both sides by 15. And x would equal to 525 divided by 15, which is 35. So for $525, we could have a dancing club membership for 35 months. Okay, so don't forget, in order to be a proportional relationship on a graph, we have to start at 0, 0, and we have to have the same rate of change throughout. So here we have another example, and in this example we also have the relationship between months and cost for this dancing club. So as you notice, our table is only filled out where our x's are. Our x's are increasing by 1. However, our cost is not filled out. So we're going to use the graph to help us fill out our table. So here, by looking at our graph, we could tell that at 0, we're starting off at $20, meaning before even participating in this dancing club, we are going to have to pay an initial fee to join. After 1 month, it's going to cost $30. After 2 months, it's going to cost $40. After 3 months, it's going to cost $50. After 4 months, it's going to cost $60. And after 5 months, at 5 months, it's going to cost $70. So at 0 is 20, 1 is 30, 2 is 40, 3 is 50, 4 is 60, and 5 is 70. So let's fill out the patterns that we could see. So our x is increasing by 1. And our y here from 20 to 30 to 40 to 50 is increasing by $10. And so if we continue on the same pattern, we'll see that at 6 months it will cost $80. So we know that each month is an additional charge of $10, and we're going to list out our rates to see whether or not this is proportional. So it's $30 the first month. Then it's $40 the second. Then it's $50 the third month. Then it's $60 the fourth month. $70 the fifth month. And $80 the sixth month. So if we simplify these, $30 per month is simplified, so we don't have to do anything with that. And then we have $40 for the first 2 months, which 40 divided by 2 is $20 a month. And then we have $50 for 3 months, which ends up being around $16.67 per month. And then we have $60 divided by the 4 months, and that ends up being $15 per month. And then we have $70 for 5 months, which ends up being $14 a month. And then we have $80 for the 6 months, which ends up being $13.33 a month. So because our rates are not equivalent, this is not proportional. So our rates are not equal. However, just because it's not proportional does not mean it's not linear. So we could still create an equation for this. So just recap. Here we have a proportional relationship in our previous example, and here this one is non-proportional. So we have our costs, which is y, is equal to, we know that each month the charge is $10, so 10x, plus we have an initial fee of $20. So y equals 10x plus 20. And using this equation, we could figure out how much this would cost for any number of months, or if we had a set amount of money, we could figure out how many months we could join this club for. So if we wanted to join this dancing club for 5 months, well, actually 5 is here, so I'll pick 14 months. So y equals to 10 times 14 plus 20. Y equals 140 plus 20. Y equals 160. So for 14 months, it will cost $160. So if we wanted to figure out now the number of months, let's say we had $220. So in order to figure out how many months that could be, we'd have to solve for x. So the first thing we do is subtract both sides by 20. And we end up with 200 is equal to 10x. So 200 equals to 10x. We have to divide both sides by 10, and x is equal to 20. So for $220, we could join this dancing club for 20 months. So that's it. Just don't forget that when we have our equation, here we have our rate of change. Which is also our slope. And here we have our initial value, which is also our y-intercept. And if we go back to our previous example, here we just have our constant of proportionality, also known as our rate of change, and our slope. So here we have a proportional relationship. So we have our constant proportionality, which is 15. We don't have a y-intercept. Well, actually it's 0. So our graph starts at 0, 0, and increases at the same rate. And here, this is the non-proportional relationship. We're still increasing at the same rate each time, but this time we have an initial value that's not 0, it's 20. So in order for it to be a proportional relationship, it does have to start at 0, 0. If we have an initial value, we don't get equivalent rates. And that's it.